Hey everyone, welcome back to your channel Technology Incredible. Today we will solve problem number 967 from the Leetcode, that is numbers with same consecutive differences. So it's a medium level problem. Let's check out the problem. We have to return all non-negative integers of length n such that the absolute difference between every two consecutive digits is k. That is okay. So here 2 points we can note. First is the absolute digit. The difference should be absolute. That is, if k is given 7, then the allowed difference is plus 7 or minus 7. Okay, and the length is also specified. The output array should contain a length of integers, and the length should be equals to n. And the absolute difference is k. Note that every number in the answer must not have leading zeros. For example, 01 has one leading zero and it is invalid. So all the numbers which contain the first digit as 0 is not allowed. These digits are invalid. They have considered that this digit as invalid. Now you may return the answer in any order. The output array should contain the numbers in any order. Now we are finding the numbers. Okay, so here n is 3 and k is 7. What is that? N is the number of digits in the output array and k is the difference between the two consecutive digits in that those numbers. Okay, so here 070 is not allowed because this 070 contains a leading 0, first digit as 0. So this it is three. There are three digits in this number, but this first digit as 0 is not allowed. So it is not considered a valid number. Now, in the next example, n is 2 and k is 1. The number of digit is 2 and the difference between the two consecutive digits is 1. So 1 0 1 2. Okay, 1 minus 0 will be 1. The difference will be 1. 1 minus 2 is minus 1. But we are considering the absolute difference. The k could be plus 1 or minus 1. So both are allowed. So let's see from some examples. First, we will consider one case in which n is 1. Okay, what if number of digit is 1 only? 1, 2, 3. Okay, these numbers contain only one digit. Okay, now 0 also contain one digit, but they in the question itself they have said that the leading zero should not be the leading digit should not be 0, and here in the one digit numbers there is only one number, so 0 we are not returning. Now if n is 1, then we will return this list 1 2 3 up to 9 because one digit number are possible, and the difference we are not checking because there is only one digit, so we will return directly this. Now what if n is 2 and k is 1? So what are the possible numbers with n 2? 1 0 1 1. Okay, two digit numbers up to 99. There are this many numbers possible with which contain number of digit as 2. But in the brute force approach, what we can do is we can traverse all these numbers and select the numbers which contain the absolute difference 1 and return add those number in the list and return that list as output. But but this is very time consuming. Okay, the time complexity is very large for this approach, so we are not we need an optimized approach. Now what we can do in the optimized approach, what if we generate the numbers? Okay, we are not traversing the numbers, all numbers. We can generate the numbers which contain the required condition. Okay, let's see. For n equals to 2, n is 2 and k is the difference is it is plus 1 or minus 1. Okay, so what are the possibility of first digit? First digit could be 0? No, it can't be 0. So what we can take as first digit is 1 2 3 up to 9. Okay, these are the possibility of first digit. Now this is level 0. Okay, we have found the first digit of this two digit numbers. Now we have to find the next digit. Now what are the options? We can add plus 1 or minus 1. So 1 plus 1 will be 2 and 1 minus 1 will be 0. So we are adding this number. We have found the first number 1, 2 and the second number will be 1, 0. So we are adding it in output list. Okay, this is the output list we are generating. Now for the next, likewise for the next number, what are the options? Either we can add plus 1 or we can subtract plus 1 minus 1, sorry. Okay, so 2 plus 1 will be 3 and 2 minus 1 will be 1. Okay, so 3 and 1. First digit is 2 and the next digit is 3, or the next digit could be 1. These are the possibilities. Like this we will generate for all the numbers up to 9, 1 to 9. Now how many levels we have to traverse like this? If n is 2, then in the second level only we will get the 2 digit numbers. But if n is 3, then we have to traverse other. For this number also we have to find the next digit. Okay, so for n is 3, then we have to traverse more. So how many levels we have to traverse like this? So let's see, if n is 3, then we have to traverse 2 times. First time we are traversing this and one more time we have to traverse. So we are traversing 2 times. And here in this condition, if n is here n is 2 and we are traversing only one time. First digit we have found directly and the next digit we will traverse. So if n is 2, then we will traverse one time. So what if n is n, if there are n number of digits, then we have to traverse n minus 1 times. Okay, this is the condition by which we will apply recursion. So this many times we will call the function recursively. Now let's see for the three digit number from this example. So first digit in the level 0 we have found out. Okay, so first digit could be 1 to 9. Now for every digit in this list, we have to find out the next digit, which contain and we have to iterate up to level 1, level 2. Okay, so we are iterating 2 times. Here n is 3 and we are iterating 2 times. That is n is, if n is n, then we are iterating n minus 1 times. Okay, so let's see for the first digit is 8. Okay, first digit we will find out all the for all the numbers, but for example here I am for explaining I am taking the for 8. Okay, so here n is 3, we have to find out the 3 digit numbers and the difference is 7. Okay, either it could be plus 7 or minus 7, because here absolute difference we are taking. Now let's see 8, what are the options? We can do plus 7 or minus 7. Okay, now what if 8 plus 7? Okay, 8 plus 7, it is greater than 10. Okay, it is actually 15 and it is greater than 10, and it contains two number of digits, but we have only one place to fill. Okay, we can't add two digits at this number. Okay, so we will rule out this option if the number plus k or minus k should be will be greater than 10 or less than 0. If it is negative also, then we will rule out that. So this path is ruled out. Now we will do 8 minus 7. What is 8 minus 7? It is 1. So first digit is 8 and the next digit we have found is 1. Now what are the options with 1? 1 plus 7 and 1 minus 7. 1 plus 7 will be 8 and 1 minus 7 is here 1 minus 7 will be minus 6 and it is less than 0. It is negative and we can't place a negative number in a number. So it is 8, 1, 8. So here it is we have found a number which is of 3 digit, and how many times we have traversed? We have traversed 2 times. Okay, we are traversing like this 1 and 2. Okay, so we have found the number 818. So we will add all this kind of number. Okay, and we will return it. So let's see for for the first digit also. Let me clean it a little bit. Okay, now we will do for 1. For the first digit is 1. Now what are the options? We can do plus 7 or minus 7. So 1 plus 7 will be 8 and 1 minus 7 is negative. So we have to rule out this option, and 1 plus 8, 1 plus 7 will be 8. So we have to find the next digit for this level. Okay, so this is level 0, level 1, and now we are finding for level 2. So 8 plus 7 is again greater than 10. Okay, so we are ruling out this path, and 8 minus 7 will be 1. So it will be 1, 8 and 1. So like this we are adding the numbers in our output list. Now let's see the code. You will understand it better. Now if n is 1, then we are returning the list up to 1 to 9. Okay, we are returning the list, this list. Now we are then if n is not 1, if n is greater than 0, then we are creating our answer list, and this function DFS. Okay, okay, we are doing depth first search. Okay, so we have written a function depth first search, and we are traversing level number of times. This level number we will pass, okay, first n minus 1, because in the first digit we are getting this 1 to 9, range 1 to 9, first digit we are finding, and then for the next digit we are calling DFS. Now if level is 0, if we reach the last level n minus 1, okay, we will decrement every time. Level minus 1 we will in the recursive call we will pass level minus 1. So when level becomes 0, then we will append the number directly. Okay, we will append this number in the output list. Now if it is not 0, then first we will find the tail digit, the last number, by taking the remainder. Now the next digit should be last digit plus k or minus k. And for avoiding the duplicacy, we are adding this number in set, because set does not add duplicate numbers. Now we have got this list plus by doing plus 7 and minus 7 in the tail digit. Now if the next digit is not negative and is less than 1, it is of one digit only, then we are adding the number. Okay, number into 10 plus next digit, we are doing this, and we are again, if it level is not 0, we have not reached the last level, then we are again calling DFS. Now like this, at the end when we reach the last level, then we will append the number and return it. Now at the end we are returning the list of this answer. Okay, so like this all the test cases will get passed. Hope you have understood the solution. Thank you.